All right, good afternoon, guys. We're going to do 3 things in this 15-minute video to give you a little bit of recap of class. First, we're going to review simplifying radicals. Second, we're going to look at adding and subtracting them. And third, we're going to look at foiling them, which you've already done a little bit of with conjugates. All right, let's do it. Okay, first thing, we're going to recap simplifying radicals. And we're going to look at a square root of, let's pick some fun numbers here. 108 x y squared z to the fifth. All right, and the first thing we're going to do, because it is a square root, notice that the index or the root is not written there. We're going to look for perfect squares. Now, I'm pretty sure the first perfect square that I notice is 4, so I'm going to divide. So that's 25, that's 27, 80, and 28, yep, okay. And I know that another perfect square in 27 is 3. Notice that 4 and 9 together make 36, okay. And so I've broken 108 down into its perfect squares. X, y squared, and z to the fifth. Z to the fifth has to be broken into 2 parts. Z to the fourth and z to the first. Then I'm going to highlight my perfect squares.
Can I show my work here, guys?
All right. Now, what goes outside the radical? What goes inside the radical? The perfect squares come out. Okay, notice that you are taking the square root of each of these pieces. 6y z squared. And then what's left? 3x z to the first. Okay, cube root. Cube root. Negative. I feel like doing 108 again so that we can see some of the differences. X, y to the fifth, z to the ninth. Okay, cube roots. This time we're looking for perfect cubes. And so I'm going to start with 108. And I'm still going to look for a perfect square and then see if there is another number. All right, so, well, I could still write 4 and 27, but 27 is 9 times 3. Okay, there's the perfect cube. So I'm going to come down here and write 27 times 4. 27 is the perfect cube this time. That's what I'm looking for. Okay, x, y to the fifth, and z to the ninth. So I need 3 of a kind. That is 1, 2, 3, 4, 5. That is y cubed, y squared. Okay, 3 of a kind. That's z to the ninth, because there's 9z. So I'm going to highlight my perfect cubes. Okay, and, oh, I forgot the negative. -1 is actually a perfect cube. Okay, here we go. What comes out of the radical? -3y. How many groups? There was 3 groups. Okay, cube root. What was left? 4y squared. Whew. All right, good job. All right, let's do a little look at add and subtract. In order to add and subtract radicals, we're going to do a little reminder here. What is 3x plus 4x equals 7x? You're like, duh. All right, but notice how these two terms have a common variable. That really means that the common part was factored out and added up, and that is how it turns into 7x. And so what we're doing in order to add variables together is we're actually looking for common terms. Right? We're actually looking for common factors and trying to add the coefficient. Okay, so let's try an example. So as I'm going to do a similar example here, 3 root x plus 4 root x. Okay, so in order to add or subtract, you're looking for common factors, which are same variable, same power, same root. Okay, see this? The common factor comes out and we add, okay, which we usually write our coefficients in front. Okay, let's write our first example down. Okay, so we're going to start with x times root 8 plus the square root of 2x squared plus x root 18. You're like, nothing's the same. I mean, this is the same, but that's all I see. So my suggestion is first simplify the radical and then look for the common factors. Okay, this is a square root, so 8 is 4 and 2. Okay, so that gives me 2x root 2. Okay, x squared. X root 2. Okay, 18 is 9 and 2. So that gives me 3x root 2. Aha! I see the common terms. Okay, I see the common variable. But I see something else that's common to every single piece. Now, when we're looking for that common factor, it's kind of like the GCF, the greatest common factor. We're looking for everything that's the same. All right, so we get x root 2 comes out, and we're left with 2 plus 1 plus 3. So there's 6 of them. Okay, 6. Usually, you put that coefficient in the front. All right, so we're going to go ahead and do a second example. Okay. Number 2. This time, let's do -3 cube root of 2x to the 5th, okay, plus the cube root of 27, okay, minus 2 cube root of negative 16x squared. Okay, and I look, and I'm looking for things that are the same. And I'm actually going to make this part here. I want this to be a 2x. Okay. All right. What do I see that is common terms? I see don't really see any common terms. So I'm going to go ahead and try to simplify. I notice that this x to the 5th actually simplifies. So we get minus 3x cubed left over 2x squared. 27 is actually 3 cubed. It's a perfect cube. Okay? Because that's 9 times 3. So this is going to be plus 3. Okay? 16. I see 4 is the perfect square. And so look at this. 2 times 2 times 2. That's actually 8 times 2. And I'm going to put the negative here. The negative is the negative 1. Okay, that's my perfect cubes. All right. And let's see. So we have minus 2x. And then a negative 2 comes out. And we're left with 2x squared. Aha. All right. Be careful with the exponents and the roots. I like to tuck my root inside. Positive 4x cube root 2x squared. And so my like terms. Oh, and I just did it. See that? I was silly. That's not an x cubed. It should just be an x. All right, look at that. It's exactly the same. That's the common factor. That's the part we're going to add. 1x cube root. And the plus 3 is going to stay. Whew, okay. All right, this time we're going to FOIL first, outer, inner, last. And we've already done a little bit of examples with our foiling, so I'm going to just bring that back here. 3 minus root 2. 3 plus root 2. Notice that those are conjugates. And so you have kind of two choices here. You can FOIL it. First, outer, inner, last. All right, look at this. Root 2 times root 2 is root 4, which is just 2. Okay, and then my inners, whoop, whoop, and my outers cancel, and I get 7. Okay, now my foiling, it doesn't actually have to be conjugates. Okay. Oh, all right. Those are not conjugates, but I can still FOIL first. Okay, so I'm just going to write this out. First, outer, inner, last. Notice that each of these things went under the same radical. All right, so I'm just going to see what I can do here. Root 36 plus root 18 plus root 12 plus root 6. And I'm going to see if I am able to add any of these pieces together. 6. Okay, so 18 is 9 times 2. That's 3 root 2. 12 is 4 times 3. So that's 2 root 3. Root 6 is nothing. Okay, so we have 6 plus, 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 no like terms. Sometimes you can't add them up. And I know I'm just a wee bit over my timing. I'm going to do one more example with your foiling. Okay, let's do two plus root 6. All right, 2 plus root 6 and root 2 minus root 12. Okay. I kind of think that root 12 simplifies because of the perfect square. And so you could simplify that first, right? You certainly could. And so I'm going to do, what is this? 4. Okay, so I'm going to rewrite this because I notice that 12 is 4 times 3, so that's A. Okay. Yeah. All right. Here goes. First. Okay, outside the radical, inside the radical. Outer. Okay, outer. Notice that that's 2 times 2. Root 3. Outside the radical multiplies inside the radical. Inner. Okay, that's root 12. 6 times 2. Minus 2 root 18. Okay, now I have to keep looking for those perfect squares. Okay, 2 root 2 minus 4 root 3. 2 root 3 minus, okay, be careful. When this 9 comes out, it's already multiplied by 2. So that's 6 root 2. Ooh, ooh. Okay, I see like terms. Remember when you used to like circle, box, triangle these things? Yes. All right, I've circled up my like terms. So I'm going to get minus 4 root 2 minus 2 root 3. Okay, and I know I'm super excited and I'm over. I apologize, but 3 minus root negative 1, 2 plus 3 root negative 1. Sneaky, sneaky, Mrs. Tabrizi. Root negative 1 is just an I. You know how to FOIL that. First, outer, inner, last. Except we know, whoops, that's going to turn into a minus 3 because that I squared is a negative 1. All right, so let's combine up our like terms. Three minus 11i. Voila! Good luck. Remember that your homework is in a new place. We're going to try it out. DeltaMath.com. Good luck.